Programmable Logic Controllers, Session 1, and Introduction. First of all, the learning outcomes for this module. There are 4 of them. Firstly, by the end of this module, you will be able to explain the design, architecture and operational characteristics of PLCs and their interfacing to the systems they control. So a PLC is a machine control device, really. If you think of it like that, that would ably control traffic lights, or a move and blow molding machine with pneumatics and hydraulics, lots of different things. Secondly, you'll be able to explain PLC to PC, personal computer, and PLC to PLC communication techniques. The use of human machine interfaces. These are kind of like touch panel screens that people can change parameters on a machine or get information from it, turn things off and on, and something slightly different, SCADA software and field bus systems and our applications. So networking of connecting PLCs and other systems together. Thirdly, demonstrate the techniques and languages available to assist in the development and structure of PLC programs. And thirdly, apply programming techniques to produce, test, debug and demonstrate a control program for a given engineering application. So you will have a go at at least 2 applications before you do the final one that is the project for your second assignment. Because on the second page we have the assessment of the module. It is 2 assignments, used to be 3, and I actually conglomerated Learning Outcome 1 and Learning Outcome 2 together and made it 1 assignment instead of 2. So you do 1 written assignment of 2,000 words, covering the first 2 learning outcomes. That's the operation and architecture of PLCs and the networking. That one's worth 40% of the overall mark, and that'll be along the lines of my usual thing for assignments: issued, can't remember whether I do it next week or the week after, but pretty early this one comes out. 2 weeks later, draft hand in. 4 weeks after issue, final hand in. Okay. The second assignment, worth 60% of the marks, is you writing a program for a given application that is of at least 50 instructions, covering learning outcomes 3 and 4, and that's 60% of the mark. But it isn't, that assignment is not just writing a program, it's about completing the technical documentation, so properly documenting the program so that somebody else can understand what it does and can fault find on it. Also writing some other technical information to the end user, and perhaps around the testing routines to prove that it does what it was meant to do in the first place. Okay, so what will happen with that one is that will be issued about halfway through the module, and it will run right till the end. So there's not like the 4-week limit on that. When we're kind of as a group ready, or someone's really ready to go with that, that will get issued, and then that will run for the rest of the time. That might even be issued before you hand in assignment 1. Okay, because it's a lengthy thing, something that a lot of it you can only do in here because you need the kit. Okay, so that is the module, and that is the assessment. Any questions about that before I move on? Right, just going to go briefly through kind of the history of and development PLCs, why they came about, and a little bit about the different types. And we'll put more, I'll put a little bit more meat on that next week. Okay, but the PLC was first introduced and developed by General Motors about 1968. Prior to that, in the 1960s, production lines and automated machinery were controlled usually with relay-based systems. And a lot, even in the late 70s, early 80s, stuff I was working on was still, even when I left there, a lot of the machines were still relay-based. So, complex production lines present problems. Reliability, due to a relay is a mechanical device. It's a mechanical, and it's got a mechanical life. So there's only so many operations before it can fail mechanically, or the electrical connections break down. But it's not untypical to have machine cabinets with as many as 200 relays in it. Certainly the ones I used to work on did. You still got any relay stuff, guys? Yeah, so you're familiar with the big panel full of relays clonking in and out all day and the heat they generate, yeah? Okay, maintenance problems, because machines become more complex, control systems are more complex. If you get 200 relays in a panel, that's amounting to 1,000 contacts in the circuit, resulting in well over 2,000 cables, because there's at least 2 connections on each of them. Thanks, Mark. So there's a lot to go wrong there. 2,000 connections, lots of contacts, get intermittent problems, very difficult to find in my experience. So the other issue is, with a relay-based hardwired system, if you want to make a change, put a modification to the machine, it often mean putting new relays in the panel that you might not have room for, completely rewiring part of the circuit to get it to work. Okay, so these are the issues with the old system, and even a small change could mean having to mount a new timer in the panel, put some switches out on the machine for the operator, and so it goes on. So what the PLC was designed as a replacement for that. And what I looked to do was design a system that would be easily programmed and when necessary reprogrammed, which they are. A solid state system that is a system based on transistors and integrated circuits, capable of withstanding harsh industrial environments. There are still wires connected to PLC because you have to get voltage out to valves and motors and bits and pieces, but a lot less, because the interconnection between all the complex contacts is done within the programming, and that's why it's easy to change. So a system, they want a system that's more reliable, easier to maintain than relay-based controls, then infrequent use, plant downtime, maintenance costs reduced. That was the idea. And also a system that was smaller and more cost competitive than the relay panels that it replaced. The industrial relays used in those panels aren't cheap, you know, and you can get a PLC easily for the cost of about 4 relays. The technology used in PLCs is the same as that used in a personal computer. But PLC is an industrialized system built to work on a shop floor and in a harsher environment than the general personal computer is. Also, in many control situations, the way they're programmed means they're relatively easy to understand how that control system works compared to if that was programmed in C or C+ or something on a personal computer. Relatively fast response to process situations. They have inbuilt timer and counter functions, so you don't have to program them yourself. They're quite simple to use. Bottom end of the range of PLCs is viable to replace systems with as few as 4 relays. And you can then also get special interfaces so that you can handle analog signals, and we'll have more about that at a later date. High-speed digital functions, temperature, and other types of control that are non-standard. Range of simple operator interfaces available, from a tiny little touch screen up to much bigger things as big as a normal PC monitor and so on, and then SCADA systems beyond that. Okay. More about the differences. PLC, designed and packaged for industrial environment. As standard, the PLC input and output connections are isolated. What that means is the external voltages, which could be high, are isolated from the internal workings of the PLC, so the processor. The reason for that is any kind of high voltage spikes don't damage the central processor because you've got that inbuilt isolation. Programming is by simple ladder diagram representation of circuit rather than complex computer programming software that requires more of a software engineer. The way you program a ladder diagram is fairly easy convertible between that and a standard electrical circuit drawing, and so engineers on the shop floor got a better chance of understanding how that works. Okay, there are some, as a recent, says a recent standard, I don't think that's that recent now, but other methods have been introduced like structured text, which is more like a kind of, if you ever done any programming in BASIC, that's more what it's like. Sequence charts and function block diagrams. I've never ever used anything other than a ladder logic, and there's never been anything I've wanted to do that I thought, oh, I'll be better off trying to learn another different way to program these things. So I tend to stick to ladder logic, and that's what you're expected to do for this module. The way the PLC stores or treats the stored program and executes it is quite different to what it would be for a personal computer. Again, we'll go through that in more detail next week, but it's got a kind of continuous scan because in an industrial environment you're going to want, there might be a delay from a minuscule delay from something, a sensor saying you need to turn this thing on to actually turning on, but that needs to be consistent, and that wouldn't, so a network for industrial computers needs to be one that it takes a consistent time for that piece of information to travel from one end of this room to the other. Whereas, as you well know, sometimes your internet at home and that network, one day that'll be lovely and fast, and another day that'll seem like it's a snail. That's no good to an industrial application. It has to be consistent. So they have more up-rated network systems to make sure that they do that. Moving on to the next page. Is there any questions before I move on to the different types of PLC? Bearing in mind that the actual history of where they came from is not too significant to the outcomes of the module. Right, typical types of PLC can sort of be compartmentalized into three areas, but the boundaries are very blurred. Okay, but unitary or some kind called block or brick PLCs generally have little or no scope for expansion. You go out, you buy that PLC with that many inputs and outputs, put it in, and if you needed more, in general you can't upgrade and add more. You might be able to buy one with more inputs and outputs, but you can't add any more afterwards, generally. The advantage with them is they can be very small, a rectangle or a cube-like shape, but kind of the size of a tennis ball, even the smallest ones these days. And they're only really that big because you need to get the connections out of them. Okay, and you'd say easily economical for a PLC like that to replace a system with as few as 4 relays, because they're going to cost you 120 quid, and you get a PLC for 120 quid easy. Moving up the scale just a little bit, or quite a bit actually, you can get quite powerful modular PLCs. What you do here, certainly with the Mitsubishi range that we use, is you buy a base unit. The base unit's got the processor in it, It's got a power supply up to a certain current rating for the inputs. You can add to you can put a separate one in if you want to. It will have certain number of inputs, certain number of outputs. So it's everything packaged that you would need to run a system. But with those, you can also buy extra blocks that you connect to it either by clipping them on or connecting them together with a ribbon cable to add extra input and output, high-speed counters, temperature control, motor control, analog input, output, and so on. And this particular range, you can add up to 8 extra blocks onto a base unit. Okay. The issue for that for me is you put a PLC in a panel and you've got this expansion capability, but you reserve some space for it, you put it in, and then a couple of years down the line they decide they want to add something to the machine that needs more input and output and you ain't got enough. Did you leave any room to put that extra block next to the PLC close enough for the connections to make? So that, for me, that's the issue. Yes, they are expandable, but there's implications there. If we go up to the top of the range, rack-mounted PLCs, this is where you buy everything separate. Everything comes as a separate entity. So you buy a rack that fits in the back of the panel. They are different lengths and got different number of slots in them. And then you can buy a cable so you connect 2 racks together and so it goes on. You then choose a power supply of suitable current rating and voltage for what you want. You choose a CPU card with a processor the speed you want. You choose a memory card with the amount of memory on it you want. And you choose all the separate input and output cards, high-speed counters that you want. Each one is a separate thing. And they plug into the rack. And so what you do is you buy a rack bigger than you need, and then you've got room for expansion, you just plug them in. The trade-off there is the cost. I mean, I'm only guessing, but I doubt you'd get even the lowest level rack-mounted setup for less than about 1,500–1,600 quid just to get a CPU, a power supply, some memory, and 1 input, 1 output card. They are expensive. I mean, you'll get PLCs cheaper than 1 card, but they are top of the range. Okay, and there are a large variety of different things you can get: digital ins, digital outs, analog input, output, temperature control, position control, and specialist safety options. They are the top of the range. They're the ones where you'd choose if you really wanted a quality solution to your task, without doubt. Okay, and most flexible, but cost. So there's always that cost and functionality balance. Yeah, everyone happy with that so far? Selecting a suitable PLC. Which doesn't appear to be in the set of notes I got. That page is not there. Anyway, we'll quickly go over it. One thing you might have to do if you're setting up a new system PLC is select a suitable one. And some of the stuff is fairly obvious, but you'd need to count up how many inputs you needed and what type they needed to be. And we'll do a little bit more about types next week. Secondly, you'd need to count up the required number of outputs, and again what type they are, particularly what voltages you need to switch. Whether there's any need to make way for expansion in the future or not. You'd be really silly if you counted up 14 inputs and 8 outputs and you went and bought a Mitsubishi PLC with just that number on it, because you're bound to have forgot something for a start, and someone's bound to come and add something 6 months down the line. So you'd normally go next one up. The power supply, do you want it to be standard AC? It might be, if you're in a remote location, you might be running a PLC off a battery that's charged up via a wind turbine up on the roof or something, and therefore you want a low voltage power supply. Program storage capacity may or may not be important. None of the programs I've ever written have got anywhere near the standard number of steps that you get in a modular PLC, but you never know. Processing speed might be important. I mean, something else from the rack mounted, the newest machines I worked on before I left the industry had a rack mounted PLC in it, and it had 2 processing cards on it. So actually, one done the analog and the other one done the interfacing with the analog and digital stuff, and so they communicated with each other. So processing speed, particularly where you want to process analog signals that are constantly varying between two extremes, then that takes processing power that you might not get with the low-end PLCs. Networking capability. Do you want to connect them together, and if so, how? And again, we'll be talking a little bit more detail about that in the later weeks. Programming software. You need perhaps to consider that. If you're a company, if you keep changing your PLC manufacturer, because this month Omron are cheaper than Mitsubishi, you've got to go and buy Omron software, and in my experience, the software for these things are megabucks. You know, and if you want several copies of it, keep changing your manufacturer, you're going to spend a lot of money. Okay, so preference for a manufacturer might be an important thing to consider, and last but certainly not least, cost. But that's just some of the things that might be important if you were being asked to select a PLC for a task. You never know, I might ask you to do that in your assignment. So, programming software. Generally, the manufacturers, in my experience, have their own proprietary software that they sell to people who use their PLCs, and it works well with their PLCs. I'm not aware of any kind of general software package that will program a range of different manufacturers' PLCs. There might be something out there, but I haven't seen it. We're using Mitsubishi. Anyone experienced with Mitsubishi PLC and the software? Has anyone done any PLC programming in this group? Michael, a little bit. Did you do your BTEC PLC module? Oh, you done yours with Phil? Yeah, okay. So you've had a go with this software then, but probably long forgotten. Yeah? They have 3 different software packages to cater for overall range of overall needs. GX Developer, that's what we're going to use. It's kind of the baseline package, and in my opinion, the best one for a job engineer on the shop floor who wants to do a bit of programming and fault find. You can program in ladder logic, the sequence function diagrams, if you so wanted to learn that, and you can document the software quite ably with that program. Then they do something called GX Works, which also does your ladder logic, and it does everything GX Developer does. In fact, although it looks more pretty, GX Developer is sitting and running behind it, but it's kind of more of a project environment. So you can also you can be working on multiple projects at the same time, have them all open and navigate between them. We have no need to do that, and that navigation takes up screen real estate that on these small laptops we don't have. So I've avoided kind of using it even though we've got it. IQ Works is an even bigger package, an integrated environment that allows you to work on your motor drive software, your HMI software and your PL software all under one project banner, which if you're making a big system is probably advantageous, but you want, you know, your 40-inch Sony monitor to be able to fit it all on the screen, perhaps, or multiple monitors. So again, although we have got that package, because we've got some HMIs, don't go into programming them on this module, but we have, I tend not to use that either, because it kind of clutters up what we need to do. Too many options for what we need. So on this course, we're going to use GX Developer. So I'm going to go briefly through some pointers about the GX Developer, what you need to be careful of in the early stages, and a quick run through of what we're going to do today in terms of getting the software up and running and having a little go with it. Do that up on the board, and then we'll get the laptops out and get the gear connected, and you'll have a go. Okay? And hopefully, oh, a bit of luck, it might work a bit better than it did this morning. We'll see. So, first thing, when you write a program and a project in GX Developer, there's a file on your saved on your memory disk or on the network, wherever you save it. It actually is a folder containing lots of other files and subfolders. So it isn't like a Word document, a single file. So this software will not like it if you try and open a GX Developer project by double clicking like you do a Word document. You need to go into the software and use the open dialog and navigate to your project and actually find it on your memory stick and load it that way. So what I suggesting that you do is, as soon as you get logged on, is create a folder on your network and or your memory stick for your PLC course. So for this module, okay. Inside of that folder, you can put your assignments and any other associated document. But your PLC programs you put inside another folder that's sitting within that first folder. So all your programs are kept separate from your Word documents and your PDFs and so on. That way you aren't going to get anything muddled, and the software is not going to kind of screech and say no thank you very much. All right. The usual thing, as most of you that were here last year are already aware, loss of electronic media is no excuse for not handing in your assignment work. So just make sure you save these things in more than one place. This is just 3 pictures of the kit that you're going to use today. So you're going to use a rack-mounted FX3G PLC. Might end up with me taking this one down once we've finished up here and getting another one out of the cupboard. There's also a couple of FX1Ns that will need to be dealt with slightly differently if you end up with those, but it doesn't matter. In terms of the programming you need to do, either will work equally as well. You're also going to need a kettle lead to actually power that rack up, so you can plug it into the mains, and then there's a switch on the front here, turn it off and on. And you're going to want one of these switch boxes so that you can have a go at actually getting a program to work and making sure it actually does what it says on tin. So that's the early part of practice, is to write programs to simulate the action with switches and make lights come off and on. Later on we move on to some traffic lights, pedestrian crossing. Do you do the pedestrian crossing with Phil? Or do you do north, south, east, west traffic lights? Yeah, well, we got a pedestrian crossing, which is slightly more difficult in terms, because it's got some user input instead of turn it on and leave it all day. Yeah. and there as a motor exercise. And then I'm now looking at what I'm going to set for the final task this year. I might change that, something a bit different. But you'll program at least 3 different applications in the learning that you do on this module. All right? So when we open the software, not very much is available. That's what opens up. And the only 2 icons you've got available to you is New Project and Open an Old Project. The rest is greyed out. Over here is the navigation area, and I'll show you that in a minute. And then this big grey bit here is where you actually write your program. You draw your ladder diagram circuit. Okay. Once you go through the steps to set up your first project, telling the software what PLC you got connected, what the processor is, and so on, then when you've done that, you then get more icons available to you, and you get some more detail in here, which is your navigation area, and you get the first or the only ladder rung that can't be deleted, which is the end instruction. So as you write your instructions, that'll keep pushing that end instruction down the screen, so it's always at the bottom. I'll see that in a minute. So I'm going to run you through that by going through that myself on the board with the laptop. I've got to switch over to the laptop because IT have rebuilt this machine over the summer and not put the GX developer software on it. That was the first problem this morning. So I'll switch that over, and I'll run through quickly what you're going to do with the software and how you upload it to the PLC. Quick run through how you enter instructions, and then we'll get the gear out and you can have a go. And if what I'm looking for you to do today in terms of practical and having a go, I'll tell you how far I'd like everybody to get. Bear in mind that the first pages after you get the software going, so that's like 21, 22, 23, 24, up to 27, is you just having a go at editing the ladder diagram without really having any understanding of what those instructions mean. You're not going to be testing those at all. It's just about some of the different editing functions and the way that you enter things. When you come to page 28, we're now going to start to talk about a real application. It's not really very technical. It's one switch turns one light on. Okay, but it's how you would implement that in a program, and about getting that actually uploaded into there, turning it all on and testing it and make sure it operates. Yeah. So what I would like is, hopefully everyone will have got to, with a little bit of help from me, perhaps to the end of page 34 today at least. So if you just put a little mark in there, if you end up having a look at some other stuff, that won't matter if you go beyond it, but I'd like to try and get everybody there today if I can.